To make sure you've all got this handout, which hopefully you have, I want to quickly briefly explain coursework 2, what you should be doing and the layout of the coursework, and then Abdul will take over to explain to you a bit of the coursework as well near the end. Yeah? Can you all hear me guys at the back?
Yeah.
Are you okay? Can you come closer? Okay, right guys, so with regard to the coursework, the first thing you need to do is include a precise definition of the underlying population of the coursework. So explaining the coursework is about GDP, what are the subjects and the random variables in the coursework. So if you look at this layout, as you can see here where you've got space, your coursework should explain what is the population. What is the population? Guys, can you not talk please? What is the population about which this coursework is about? What are your inferences going to be about? What are your conclusions going to be about? Then what you need to do is indicate clearly what the sampling frame is. So explain what is the sample, the sampling frame, the data that's given to you. After that, the sampling section. So you are given certain data, different countries, and you're given particular information about this data. You are given 3 variables. You are asked to look at the relationship between 2 of the variables and then another 2 of the variables. So you need to either use Excel or a graphical calculator, but not both, to obtain at least 35 distinct random numbers. So I'm sure you have been shown this as an example. You could easily use the rand between function, defining what random variables you want, which population you're going to use as your sample. Okay? Can you please sit down? Right, so guys, look at this point in red. You can either use Excel, run between function, or you can use the graphical calculator to obtain at least 35 distinct random numbers. These random numbers are then to be used to construct the sample. So what happens is you have 35 different countries. You have data for 35 different countries, X, Y, and Z, which you can, in the coursework, put here. So random numbers generated. Here's a list. Country 5, country 25, country 96, and so on. Then you put the results here, 35 different countries. Country 5, X value is this, Y value is this, Z value is this, GDP this and the other. And the key thing to note, guys, in this section is this. This sample of 35 countries, which you've taken once, this sample will be used for both of the tasks in the coursework. So both comparisons. The same sample needs to be used. Hence, it's in capitals. Remember that point. And so, sampling, explanation, 5 marks. Are we okay with that, guys?
Yes.
Good. The next thing. Once you have that sample, once you have those 35 countries, you're going to produce a scatter graph. And the scatter graph, we will give 10 marks. So some of you lost marks in the last coursework because your graph was not clear enough. The axes were not correct, the axes were not labelled. There was no title to the diagram. So you can see clearly what you need to do. Have a title. X-axis labelled correctly, Y-axis labelled correctly. Excellent skills. You know, there's no point seeing a graph which, you know, there's the page and your data is like there. Useless. Doesn't give you any idea of population. When you're asked to comment on this graph, you can't comment on this graph. All the data is there. It doesn't make sense. How can you say it's jointly normally distributed or what kind of population it is? 10 marks for that. Right, so so at this stage where you have your graph, do not do the line of best fit. Now think about this, yeah? What does the line of best fit mean? It means you are saying there is a relationship between X and Y. But have we found that? Have we concluded there is a relationship? Have we said that this is linear? We haven't said that at this stage. So putting a line of best fit at this stage, and even though we tell you every year do not do this, we still see people doing this, will lose you marks. Critical marks, a lot of marks you will be lost because of this. Are we clear on that? Okay. Right, then you need to comment on the scatter graphs that are produced. Comment on whether the graph shows there is evidence of correlation. Is it linear correlation? If the diagram shows evidence of correlation, comment on whether you are justified in using a model with two variables. So you're going to make a comment, is it jointly normally distributed? If the data is non-linear, consider linearizing your model. So you might not get data which looks like this. You might get a different shape. What happens then? Maybe the data looks like, or your graph looks like that, X and Y. Now look at this. It is not jointly normally distributed. It is not a linear relationship. So what happens in that case? What do you do? Linearizes the graph, the data. So let's have a look. How to linearize the problem. So we use Excel to find the most suitable linear form for your scatter graph. So let's have a look. There's the data. Okay, that's my data. So if I draw a scatter graph from here, you guys have seen this before already. Insert, scatter, click on that, and you can see there's a scatter graph. Make sure you label the axes, give it a title and so on. So this is not a linear graph. Yeah? Okay, so what we'll do is if I click on layout, trend line, more trend line options, and if I click on logarithmic, you can see that line seems to fit that data. Additionally, if I click on display equation on chart, I can see that is the equation in this case. Yeah? So this tells me this graph is not linear, it's a logarithmic relationship. So that was my original data, X and Y. What I'm going to do is click on define a new variable called H, and if I click, can you guys see that?
No.
What it says there? Okay, let me tell you what it says in that function. Okay. So, in here, it says equals log of A2. And when I click on log of A2, and I take this down, it gives me these values. So I've just done log of 40, log of 70, log of 120, log of 150, put in here, copy the Y values there. And what happens now, when I look at the scatter graph of this data, seems a bit more linear. There. So the linearization process essentially gives you a linear graph, which you could talk about later on. Yeah, so are we clear? So your courses most likely will have an element of this. Okay, we have to linearize the actual x and y to h and y. Okay. So redefine the variables for the linear model and make sure, so what happens is, this is the scatter graph you include into your coursework. This is the scatter graph. There's no need to include this one. This is the key one you need to include. Okay. Right. Also, what you need to do, once you have this data here, so look at the data which is in green. Once you have this data here where you've got h, which is log of x, and you've got y, you are going to show in your coursework what your new data looks like, what these values are. So, going back, so here your explanation is, where you've got dotted lines, this is not a linear relationship, it's not jointly normally distributed, looks like a logarithmic relationship. This is my h and y, log of x, these values, log of y, these values, for the 35 data values you had. Are we clear on that, yeah? Okay, so, once you have that, put this into your coursework. Comment on this. Is it jointly normally distributed? Does it seem like a linear relationship? Okay, and once you have done this, you use Excel to find the Pearson's product moment correlation coefficient, which you all know about, yes? Yes? Okay, so, let's have a look. Here's my data. I'm going to copy this into a new sheet, paste values, and then to find equals Correl gives you the Pearson's product moment correlation coefficient, this function there. Click on the first row, which is h, type the comma, and click on the y column. Close brackets, and this should give you a value which is going to be 0. Whatever it is. This is the correlation coefficient for your data, indicating whether, when you compare it to the critical value, is there evidence of correlation, a relation between the two variables. Okay. Are we clear on that, yeah? You okay with that?
Yeah.
Okay. And that's explained there. Copy the table of the linearized model onto the Excel spreadsheet. Calculate PPMCC using the correl function. Paste the table obtained and the value of the correlation coefficient into your course WIFP document. So you're explaining what values you got, you're explaining what data you obtained, and that's 10 marks for that section. Are we happy? Yeah? Okay. What's this testing? Abdul? This section?
That's what you're going to go without. Surprise me.
You doing fasting, Abdul?
Okay, and I'll try to follow this very difficult argument by answer. Now, can I have your attention, please? I think the main idea of the coursework is that is there a correlation between X and Y at the population level, okay? And the issue is settled by the value of rho, the correlation coefficient, okay? So we carried out all these tasks up to and including calculating PPMCC, okay? And we'll now use PPMCC to decide the issue of where, if there is evidence of correlation or not, okay? And all this decision is encapsulated in what we call a hypothesis test. We have a very formal procedure at the end of which we decide, we make up our mind if there is evidence of correlation at the population level or not, okay? And it's very important to be strictly formal when you write your hypothesis test. And this is how it is written. We start with H naught and then H1. H naught, which is technically called the null hypothesis, states that there is rho is equal to 0, which is tantamount to saying there is no correlation between the variable considered. Remember, the variable considered are H and Z, the linearized variable. Okay? You see, as soon as you linearize the variable from that point until the ending of the task, you work with the linearized variables. Okay? X doesn't appear again until at regression stage. Okay? So you leave X rest for a while. Yeah? Work with H and Z. Okay? So therefore, the Paris hypothesis says no correlation between H, is it Z or Y?
Y.
H and Y. Okay. At, if you really want to be precise, no correlation between H and Y at the population level. This is the Paris hypothesis. The Paris hypothesis says so. Okay. Now, the alternative hypothesis is rho is different from 0, and this is the same thing as saying there is correlation between H and Y at the population level. Okay? This is how you write. This is the way to write it. Okay? This is H naught, null hypothesis. This is H1, the alternative hypothesis. And at the beginning, okay, you have to decide on a significance level, probability of a type 1 error occurring. Okay, you have to make a decision. I'm going to work, for example, at the 5% significance level, the 1% significance level, or whatever. Generally speaking, as explained to you during the week, the most used significance level is 5%, and this is a two-tailed test, which means when it comes to selecting your critical values, it will be from the second column. Okay? So, and then you continue. You are going to look at this is what you are going to write at the percent significance level. the critical value. And this is going to come out of the table, of course, yeah? You're going to look at the table and produce a critical value. Now the critical value is decided by two considerations. A, the fact that this is a two-tail test. B, by the value of the critical, by the value of significance level you started with. As soon as you decide on these 2 points, then that will select for you a column to use your critical value from. As I said, most people select or choose the 5% significance level as their significance level, and this test is obviously a two-tailed test, so that means the second column of critical value. Okay? And the other consideration is of course the value of the size of your sample. So the size of the sample, significance level, two-tailed test, and then you'll be able to pick out the correct critical value. Okay? What do you do with this critical value? Then you compare the critical value obtained to the calculated PPMCC. So there are two things that might happen, either greater than or less than. Okay? In case of greater than, so just to concentrate, to focus on what I'm talking about, I'm going to just select the greater than option, greater than PPMCC. That's the value obtained, you obtain from your calculation of the PPMCC using your sample. Okay? Now, if this is the case, okay, then you're going to say, consequent of this, built on this, consequently, we, anything, I reject. Is it reject or accept? I accept.
Accept.
I accept H naught, okay, based on this. I accept H naught and conclude that there is evidence.
No.
There is no evidence. There is no evidence of correlation at the population level. And this is as precisely stated as can be. If you drop a single word, then the whole thing becomes untrue. Okay? Should you drop, for example, the word evidence, the whole statement becomes not true. Okay? This is stated very, very precisely. And if you really want to get the total, remember, there are 20 marks for this section. This is actually the main section in the coursework as far as correlation is concerned, okay? Because this is the point at which you decide whether there is evidence of correlation or not. Because that is the main question in the coursework. Is there correlation or is there not, okay? And this is when decision on the main part of the coursework is made, okay? Now, well, let's just talk attention, please, a bit about the breakdown of these 20 marks. There are going to be 2 tests, one for task 1 and one for task 2. Okay. Now, the marks are going to be divided 5, 5, 5, 5, 4 5s, yeah? 1 5 for that one, stating that very clearly. 1 5 here, 5 here, 5 there. Is that correct? There are 5, yeah? The statement, the proper format of the hypothesis test is 5 marks. Justifying the significance level is 5 marks. Obtaining the correct critical value is 5 marks. Stating the correct conclusion is 5 marks. That's 20, okay? Is that clear, everybody?
Yeah.
Yes. Okay. Of course, actually, to be precise, you're going to have 10 marks for each test. Okay, so there are going to be 2 tests, one test for each of the tasks. Is that clear? Okay. Now, hopefully, having negotiated this part of the coursework successfully, then you move on to the last part of the correlation. Okay? Attention, please. Now, this part will be included only if you reject H0. Okay? So, at the stage of the hypothesis test, there are two possible outcomes: rejecting H0, accepting H0. So, if you accept H0, you do not include regression. You still get the total marks. Yeah, you still get the marks for regression. But the correct thing to do, the logical thing to do, if you reject H, accept H0, you do not move on to regression. Actually, if you move on to regression after accepting H0, you will fail. Okay? Because accepting H0 means there is no correlation. Including regression means there is correlation. So if you say there is correlation, no correlation at one point, and then move on to the next step and say there is correlation, then that's a fail. Okay? So you include this, it's written in red. You include this before you go into regression. Ask yourself, have I rejected H0? Okay? If you have rejected H0, you move on to include regression. If you have not rejected H0, sorry, what am I saying? If you have rejected H0, you include regression. Okay? Yeah. If you have accepted H0, you do not include regression. Is that clear, everybody?
Yes.
Good. Now, regression. Regression means drawing a line, a scatter graph, and imposing or superimposing a line of best fit on the scatter graph, and then reducing the equation of the line of best fit. Drawing a scatter graph, superimposing the line of best fit, and then getting the equation of the line of best fit. That's regression, okay? And the line of best fit is also called the regression line. It's just a different term. There's two different names, yeah, for the same thing. Now, there are also subtasks here, okay? The first thing you have to actually make your mind up about is to decide on looking at H and Y. Which of these is independent variable? Which variable affect the other? Okay? And once you have this, identified the independent variable correctly, then on your scatter graph, the independent variable goes along the x-axis. Okay? And then, of course, you still have to pay attention to the standard of the graph. It still has to be a quality graph. Quality as defined earlier on in one of the slides, meeting 6 requirements. Okay? So you add the line of best fit and explain the equation. And can I just give you a couple of things, couple of points about the equation of line of best fit. The equation of the line of best fit, in this equation, you use values of the independent variable to make prediction about the dependent variable. The independent variable is most likely to be h in this case, yeah? So you use values of x, h, to predict values of y, okay? Now the predicted value of y is not a definitive value. It's not a precise value. You are not going to say when h is this, y is that, yeah? You are going to say when h is this, y is most likely to be that. Is that clear? Can you see the distinction there? So therefore, the equation of the line of best fit is used to make prediction about expected value of the dependent variable. Okay? So you have to explain this point clearly in your own words, of course. And explain, and then move on. Interpret the gradient. Interpret the gradient with reference to the context. I think basically what this is about is the following. Now there's an equation of a straight line here. Y equals ax plus b, okay? Now, because you studied coordinate geometry, if I ask you what is a, you're going to say to me it is the gradient. Is that correct? If I say to you what is that capital A, the answer is the gradient, yeah? Yeah, but if somebody in the supermarket asks you, somebody meet somebody in the supermarket and say to them that is an equation and A is a gradient, yes, they're not going to understand that, yeah? If you meet somebody in the street and say A is a gradient, they will not know what you are talking about, okay? So therefore what we need here is to describe the gradient in a manner that anybody in the street or anywhere else will understand what you are on about it, okay? And the way this is done is as follows. You can, if you say to somebody, A is the increase in Y corresponding to a unit increase in X. You say that to somebody, that's exactly what A is, okay? That's exactly what A is. If you say to somebody, capital A is the increase that results from increasing X by 1, I think anybody in the street will understand that, okay? They will. or at least they stand a better chance of understanding that if you say A is the gradient, okay? Okay? And finally, to finish your job on regression, you have to produce one prediction using the equation you obtained from your regression line, okay? One prediction means you just write when X is, if this is your equation, of course you are going to be working with H. Just write when H is 10, Y is 10A plus B, whatever A and B are, yeah? Just write down this. But you see, you have to be very careful. When you make predictions made on equations of line of best fit, you know from before Christmas that you can only make prediction from within the range of the values of H in the table, yeah? So you cannot make prediction outside, but subject to, if you just pay attention to that point, you'll be okay, okay? And can I say to you, don't ever try to interpret the intercept if 0 is outside the range of H. Don't mention the intercept. Is that clear? Because you will be doing exactly what I said you shouldn't do a minute ago. I.e., you can only make predictions within the range of values of X, of H that you have got. So if 0 is outside, if you say the intercept is this, you are making predictions outside the range. Okay? So the one thing that you can always predict all the time is the gradient. Forget about it. Now, this is task 1 finished. Okay? Task 2 is, apart from the fact that there are 2 different variables, is exactly the same. So you'll have task 1, you finish task 1 full stop, and then move on to task 2 and you replicate everything you did in task 1. Is that clear? Yes. Okay, so task 1, finish. Task 2, you finish task 2, okay? Now, what ties, attention, task 1 and task 2 are tied up in one conclusion. So there's going to be one conclusion tied up, task 1 and task 2. Is that clear? Yeah, so please don't write a conclusion for task 1 and a separate conclusion for task 2, because that's missing the whole point. Yeah? So there's going to be one conclusion for both. Now, why is that? can we just try to go on to conclusion bit? First of all, before I go into details of what these bullet points are, okay, well, let me try to tell you a few things about this coursework itself. Now, this coursework studies the impact of GDP on two other variables. The other variables are life expectancy and infant mortality rate. Now, GDP in this case, listen to this, is used as a measure of a wealth of a country, how rich a country is. Okay? The other two variables measure the state of health of the country. Okay? So what we are talking about here is the impact of a wealth of a given country to the health services provided by that country. Is that clear? So that if you had this coursework, for example, in sociology, that's what they have asked you to do. Discuss the impact of wealth on the health services of a given country. Okay? That would have been the coursework in English then. Okay? It is the same coursework. Okay? But here, as opposed to there, we are using actual evidence of what we are doing. Okay? So therefore, the conclusion that you are going to write up is going to be pretty much along the line of what you do in other subjects. But you are going to be very specific, referring continuously to evidence. Okay? So, and we don't really want you to go going round in circles using unnecessary sentences. Yeah? If a statement can be expressed in one sentence, don't write two sentences. Okay? So if you think your ideas are completely captured in 5 lines, that is enough. We don't want more. We don't want 6 lines. Okay? Remember, I'm talking about, this is the point, talking about one variable measuring the wealth of a nation and the other 2 variables measuring the health of a nation. Okay? So as soon as you begin to look at the problem in this light, then you will realize that the 2 tasks are not separated from each other. This is one thing. Okay? So that's what you are going to address in your conclusion. Okay? Right. So look at just the body of the conclusion itself. The conclusion, the total marks are not written, but there are 20 marks. You just make a note of this point. 20 marks. And there are 3 obvious subsections to that conclusion. The first part is you have to summarize what you found in the 2 tasks about the variables. Now, summarize here means something very specific. Okay, stating the result of the hypothesis testing, what you actually found there, and what you found, the equations you found in your regression lines. Yeah. Okay, stating things very clearly. So you are not going to do anything fancy. You are going to go to the body of your task 1 and task 2 and then pull the results into the conclusion. Okay. Now that is 6 marks out of 20. 6 marks out of 20. Okay. Now we move on to the tricky bit, analyzing the findings. That's a bit like your coursework in other subjects, okay? Analyzing, okay? Now, one of the things that you can think about, do you think your findings are in line with what you expect? Do you expect, are these findings surprising to you or not? Okay? So you have to address that point. And if they are not surprising, you think of an explanation why they are not surprising. If they are surprising, you also think of an explanation why they are surprising. Okay? And the other thing is to discuss some of the assumptions in the work itself. There are implicit assumptions like GDP measuring wealth. Is GDP the best measure of wealth? Okay? If you go back to your economics study, you know there are things like GMP, which can be used as measures of wealth. So therefore you have to discuss this point. Am I using the correct number to measure wealth here? Okay? And am I using the correct variable to measure health? I mean, shall I use, for instance, rate of HIV in the country or whatever? I mean, there are so many variables that you can use to discuss health. Are these enough? Are these going to give me a correct information about it, and so on? Okay, so that part is very important. It's pretty much in line with your other coursework. Okay, so when we talk about analyze, evaluate, whatever you are told to do in but and it's a big but. I don't want waffles just going around in circles and writing things, and we don't have a word limit and all that stuff. Yeah, you just write concise and to the point. Finally, the last. So that's, I'm sorry, that's 8 marks. Okay, that's 8 marks. Okay, and last part says suggest an extension. Do you need, for example, there are various ways of extending this task. Okay, I can include more variables. Instead of having 3 columns, I can have 3 variables. I just mentioned things like rate of HIV, whatever infection, or rate of cancer or something. You know, can always add various variables, GDP and GNP, etc. Okay, so you can think of extending along these lines. You can also suggest improvement, like you can pose the question: is the sampling frame enough? Shall I increase the sampling frame? Shall I increase the sample itself, and so on? Okay. Shall I use multiple regression? I mean, there are various things you can do. Okay. And that is 6 marks. 6, 8, 6. Now, as it happens, just make a point here. Last year, marking this section, from what I can remember, the highest mark was 12 out of 20. Okay? So, no, I'm not saying I'm not going to give you more than that. That's not what I'm saying. What I'm saying is, if you really want more than that, you spend some time and some effort here. Okay? So don't write anything that comes to mind. You know? I think that's it. Now, if you have questions, you can ask now. Okay? And I'm advised to you, pay attention please. We've got about 10 days until you hand in the coursework, okay? You start quickly, because no amount of advice is going to anticipate problems, okay? So every student is working with a different sample. You might hit a problem at any point. So the sooner you start, the better chance you will have of your problem being dealt with. So if you start, for example, today, and you have a problem on Monday, and then you come to CF17, we can help you. But if your problem occurs on Sunday, before handing in the coursework, you are on your own. Okay?